Perfect, thank you. Okay, my name is Boney Bruno. I'm with EMC. I'm just curious before I kick this off, by a show of hands, who has heard of EMC Isilon? Now, keep your hands up. Who has deployed EMC Isilon with Hadoop? All right, we got half and half. My goal today is to discuss EMC Isilon as well as some Hadoop failure scenarios and get into some testing I've done, which will be interesting to you. As far as what I do for EMC, technically I don't work for Isilon at all. I work for corporate under the Emerging Technologies division of EMC. And what that means is all our emerging technology products, Isilon being one of them, DSSD is another, Scale.io is another for software-defined storage, ECS, or Elastic Cloud Storage, all these products I am responsible for in one way or another writing white papers, doing performance testing, integrating these products with third-party solutions. Some of our partners here in the booth as well, I've done validation tests for. So my job, I love it. I get to play with million-dollar equipment and million-dollar data centers and just test and write papers and do integration testing. In fact, IBM's here. I wrote the implementation guide for Big Insights on EMC Isilon. So we are completely certified with Cloudera, Hortonworks, IBM Big Insights, as well as Pivotal, which we own. Anyone familiar with Hawk or HDP? Have you heard of that? So that's an up and coming. There's a lot of buzz around Hawk, which I'll get into as well, which will be interesting. So the agenda for today, let's analyze some Hadoop behavior under different failure scenarios, and let's review how EMC Isilon addresses those to improve resiliency, performance, etc. My background has been in open source for many, many years. I was very skeptical when I came to EMC, to be honest with you, if this solution would work in a Hadoop environment. And I could tell you, 600 customers later who have deployed this in production at a fairly decent scale, it does work, and there's some cases where I wasn't expecting it to perform as good as it did, and it performed very well. So we'll get into some of those scenarios in addition to the use cases. So I'm assuming, being a Hadoop summit, Hortonworks is the key sponsor for this. How many of you have run Hortonworks? I'm just curious, from a distribution, keep your hands up. Is it all Hortonworks, or do you have a mixed environment of Cloudera and some other solutions? All Hortonworks, okay. One of the unique things about EMC Isilon, we ran into situations where customers were running mixed distributions. So one of the cool things about Isilon is you can actually run Cloudera, Big Insights, Hortonworks simultaneously on this platform. So when it comes to data migrations, or maybe you want to move from one platform to another, very easy to do with this technology. For the sake of today, there's a lot of things to consider with respect to a Hadoop rollout and implementation from data governance. By the way, we make, as I said earlier, I spent a lot of time validating third-party solutions. If you get the time today, Blue Talon is a product that we now resell at EMC, and it's a very powerful solution for data governance. And it's fully validated with this platform. So they're here in the booth, and if you want to know more about them, I've done the validation test myself. Very, very interesting data-centric security solution. So that's a shout out to anyone looking at security. I've done some tests there and I really like their solution. As far as data access security operations, what you'll learn is that HDFS, that protocol, is the central piece to Hadoop. That distributed file system is critical. And what we've done at EMC Isilon, and we're really one of the few commercial entities out there pushing this, is we built that protocol natively right into our storage operating system. And that's what you're going to learn today, is some of the benefits that gives you operational-wise, security-wise, performance-wise when doing that. If you've ever looked at that protocol, there's a lot going on in terms of remote procedure calls, TCP/IP communication. It's heavy, and it's heavy depending on reads, writes, deletes, streaming, what you're doing. One thing that you'll notice, though, that name node is critical to your infrastructure. And in terms of a design, there's only one active name node per cluster. And personally, I don't think that's the optimal design, to be honest with you, because when that fails, even though there's an HA and you have to move over, there's a convergence that takes place. When a data node fails, there's also a convergence takes place, and there's some administrative overhead that needs to take place and some work that you have to do. It affects performance, data, job performance, et cetera. So what we've done at Isilon is focus on how do we improve the data node resiliency and the name node resiliency. Because when a data node fails, without question, your job input and output would get affected. So I'm just curious, by show of hands, how many actually run Hadoop clusters? Are you administrators, any, or a few? Others, management? So you got a mixed bag. All right, for the managers, this may or may not make sense, so just bear with me. There's a log message. You know, Hadoop's very big on logs, and what happens when there's a data node going shut down, you'll actually see this data node is shutting down message in the log, your Hadoop log. And you'll also see errors in Java, input-output exception errors, et cetera. HDFS, by design, does not decommission when a single disk fails. Even though there's some enhancements going on with hot swapping data nodes now, or drive failures, you still have to do some work. But what's driving this is this property called DFS, data node fail volumes tolerated. By default, it's 0. You want it to be 0. What happens if you don't make it 0? You risk data integrity, right? You could lose data. So by design, you know, if from a system administrator perspective, you may want to think, well, let's increase this so I could be a little bit more fault tolerant. But as a data scientist or Hadoop administrator, you don't want to do that. You cannot risk data integrity and data loss. So we keep this at 0. And if it's a DAS deployment, everyone know what I mean by DAS, direct attached storage. That's historically how you roll out Hadoop. And I'm not here to bash DAS at all. I'm here to just point out an alternative solution to DAS that a lot of people, and many of you may not be available, and how you would deploy that and integrate that with your Hadoop infrastructure. But with DAS, you would stipulate your different values for your data amounts. In this case, data 1, DFS, data 2, DFS. These are your mount points. What happens when the data node fails, in terms of recovery steps, you're going to have to replace the hardware, you're going to have to restore the data volume, make directories, change permissions, and restart the data node. Even if you implement the latest hot swapping technologies, you probably just remove one step from here. There's still overhead that you have to incur administratively to recover from a data node failure or multiple disk drive failures. That being said, what we have done at Isilon, I'll get this into, I lost my clicker for some reason, it's not going forward. I'm sorry, that's his fault. Let me speed through this again. A task tracker, I'm going to get into task tracker as well. So what's the impact? If you're into statistics and research, one of the best documentations on research in Hadoop failure scenarios, if you want to take a note of this, so these slides will be available. But Florin and Eugene at Rice University did an outstanding job on testing failure scenarios and job performance and what happens. I'm going to summarize some of the stuff from their research as well as stuff we've done at EMC. But basically, here's one thing you could take and you put in your pocket in terms of job time, Let's say you have a normal job time that takes 220 seconds without any failures. Just to give some perspective on this, you could see that increase from 220 seconds to over 1,000 seconds just if a task tracker fails. And if a data node fails, which was the previous scenarios, that could jump up to 700 seconds. This is just the reality of Hadoop, okay? It's just one of the pain points. Now, although it stays up, and Hadoop is fault tolerant in terms of it scales out and the jobs keep running, there is an issue with performance. And we've kind of, when you really hit hard on the Hadoop distributors, they don't give you this information readily. It's kind of kept under the table. They don't really have good statistics on what happens with different failure scenarios. And look at the Rice University test. That will be very beneficial to you. Now, what did they discover? What have we seen? There's a speculative execution algorithm that Hadoop uses to track failures, okay? And what happens is, in the process of a failure, that can have a negative impact to the SE algorithm. A data node is an example of such a failure where the SE algorithm can kick in. In some cases, you want to disable this altogether and just let the data node failure and not have to let Hadoop try to figure out, is that guy up? Is he up? Is he up? No? Okay, shut him down, because that delay can cause a problem. So Facebook, I believe LinkedIn, some of their deployments actually disabled the SE algorithm altogether. And by default, it's enabled, and that's the algorithm used to track when things go down, data nodes, task tracker, et cetera. Second thing, Hadoop tasks are not good at sharing failure information. So it's not as optimized as you would think in terms of if something were to fail, having other jobs know about the failure and what caused that failure. That kind of sharing of information, not very good in Hadoop today, okay? And this will temporarily overload conditions when these failures occur. You may see TCP resets, connection issues, and just jobs excessively failing. With Isilon, what we've done, and keep in mind we did this 10 years ago, and we have implemented erasure coding over 10 years ago. So how many have played with erasure coding with Hadoop? Have any of you? One? I'm just curious, what results, performance results did you get when you enabled erasure coding? Yeah, that's what I hear from a lot of people. In fact, Hortonworks, since this is the Hortonworks Summit, they will tell you enable erasure coding just for your archive partitions and not the production high performance partition. With Isilon, you can't disable erasure coding. We've mastered erasure coding. We're very good at it. And keeping in mind that HDFS, that Hadoop Distributed File System, technically is running on top of another file system, right? If it's a Linux deployment, it's HDFS on top of ext3 or ext4, and there's overhead there. Isilon has a single file system volume, and every one of those nodes, guess what, runs a name node and runs a data node. And because we have so much storage, the metadata is on every node. And on top of that, I'll get into some other slides here, but this is how we at EMC resolved a lot of these data node issues, a lot of the name node issues, and the convergence time associated with those failures. A customer just called me yesterday. It's a very, very large telco customer who, up until HDP, was it 2.3? Rolling upgrades weren't supported, right? So if you were on HDP 2.2, 2.1, 2.0, and you wanted to upgrade, it was kind of painful. In fact, you would basically have your cluster, back up all the data, upgrade the compute nodes, restore all the data. It took time. With Isilon, all the data is already on those name node and data nodes. We are the name node and data node for the entire cluster. So think about that. All the data's there. I need to do an in-place upgrade. Even for a Hadoop distribution that doesn't support rolling upgrades, all I do is just upgrade the compute nodes, point to my name node and data node, all my data's there. No backup, no restore, very powerful. This is an operation benefit that you get from EMC Isilon that we hear over and over and over again that they really appreciate. On a standard Hadoop cluster, you only have, as I said earlier, the one name node. And in many cases, you have to land that data into your staging environment. So here in step one, I'm saying data is copied or landed into this landing zone. Data is copied from there 3 times because by default you make 3 replications, right, for data to maintain high availability of data. And then your compute and data is basically running together on all your worker nodes. In this case, I'm saying map reduce, but that could be Spark jobs. It could be anything that you want. With customers that have Isilon, in many cases, Isilon doesn't just support HDFS. We support Swift, we support FTP, HTTP, CMB, NFS. So in many cases, that data is already on Isilon. So we could do in-place analytics right out of the gate. This concept of a landing zone and moving data only applies to Isilon if that data doesn't have to be there. If it's not there, then yes, there's going to be some data copying, whether you're using NiFi, whether you're doing EDW offload, whatever the mechanism is. Once the data is there, though, you can run analytics, boom, in real time, which is very cool. Scale out NAS. Every one of these nodes, again, I'm going to get into some performance numbers, but if you want to quickly figure out how does Isilon scale in Hadoop, every one of those nodes gives you roughly 2 gigabytes per second of HDFS throughput. Pretty powerful. And you could scale that out to 144 nodes to put that in perspective. And every one of those nodes can give you 35 terabytes. So on the high-end nodes, easily, a single cluster could give you 20 petabytes of storage with a utilization of 80%. You know what the utilization is on DAS, on standard Hadoop, when you add in the swapping and the copying of data and the 3 copies? 20 to 25%, big difference. Now, in addition to running name node and data node across this, guess what the data nodes communicate on? It's not SATA, it's not SAS controllers, it's InfiniBand with nanosecond latency, and a lot of that instantaneous detection of a failure will happen at a nanosecond time frame within Isilon. And it'll basically unallocate itself from the cluster without you as an administrator having to do anything. So, in terms of our vision at EMC for better Hadoop, what if you can implicitly increase high availability automatically? And by that is, as I add nodes, I add more name node redundancy, I add more data node redundancy, I simultaneously scale out, and every one of those nodes, I forgot to mention earlier, comes with 2 10 gig interfaces on the client-facing side, in addition to the 2 InfiniBand interfaces on the data side. So it's every time you add a node, it's another 20 gigs of throughput. In a couple of months, that'll be 2 40 gig interfaces. So we're just increasing. In fact, we've doubled our performance with HDFS throughput just with the latest 1FS release that we came out. As I said earlier, erasure or coding is built into our file system. So HDFS, we don't run Apache HDFS code within our storage operating system. We built an HDFS interface into 1FS, much more efficient, and it's written in C++, much faster. As much as we love Java and things like that, it doesn't compare to speed in embedded systems like Isilon when you can go to C or C++ natively, right? So there are some engineering optimizations we've done to make our HDFS available to your Hadoop cluster. Let's see what else. There's a concept of an access zone. I didn't list it here, but what we do within the 1FS partition is we basically can create as many partitions as you want. Each partition will have its own user base, its own namespace, so that's how I could run Hortonworks and Cloudera and IBM Big Insight simultaneously. If I need to move data, actually I don't even need to move data. We can enable a feature to make that same data available to multiple Hadoop distributions, which is very cool. And that's configurable. Why do I say this? The reality is, from my perspective, the apps drive the choice of the Hadoop distribution you're going to roll out. In many cases, if you're a telco, Comms Reveal is an awesome product made by BCA, I believe is the name of the company. They do call detail analysis and all kinds of forecasting. They only run on Cloudera right now, right? And then you have certain GE health applications only run on Hortonworks and Pivotal. So in many cases, depending on what you're doing at what time, you may be forced to run multiple Hadoop distributions. This platform makes that easily available for you to do. Now, we built this for big data in mind 10 years ago, right? We're the only storage company that could scale a single volume. Technically, it's 20 petabytes using the fastest nodes, but if you want to create a cold archive, that can grow to 63 petabytes in a single volume for your Hadoop on one cluster. You can get an aggregate throughput of over 118, actually that's jumped up more, gigabytes a second, you know? 740 megabytes of single stream throughput. It's very, very powerful, and at the same time, we're running all these multiple protocols. There's a new feature that we recently added that I'm going to get into in a couple of slides here. If there's any questions, feel free to interject at any point in time. So if you were to look at a legacy deployment of DAS, the main difference is that name node and the data node has been moved completely off of the Hadoop cluster. Now, what I could tell you, since I'm a performance engineer, there's some added value there, right? Because if you look at when a data node, and we'll just use MapReduce. I know a lot of you may be using Spark and other stuff, but let's just use MapReduce because everyone seems to be familiar with MapReduce. There's a shuffle phase, right, with your MapReduce jobs. And that uses your local disk, right? Because all you have is local disk with DAS. So if you're shuffling and you're also reducing and you're running other jobs, you're running a lot of I/O contention on that single disk controller. Here, we move all that over to Isilon, and now your compute node is segregated from your storage node. This becomes even more valuable as you start migrating to Spark jobs, because Sparks are memory CPU bound. Your computes now are going to be used for compute and memory processing, and you leave the storage to us. That's what we're recommending. You could run your own tests, and you'll see, you know, there's always going to be a depends scenario, right, depending on what you're doing. But in many cases, this technology, this platform alleviates a lot of those other problems we said earlier. When you add in the fact that we support these multiple protocols, Swift isn't here, I should have added Swift. And there's a concept of cloud pools that I'm going to get into in a second too. It's really cool in terms of time to results and getting to in-place analytics. If you look at DAS historically, you're going to look at 5 copies. Normally the existing primary storage will be mirrored, and you may have a couple of copies there. And then using the 3-count HDFS replication by default, you can easily end up with 5 copies of the data with a storage utilization, as I stated earlier, of 20, 23%. And then when we run into situations with our customers when they need to move data, either do upgrades or maybe they're doing a change of data center, you know, it could easily take over 24 hours, you know, to transfer hundreds of terabytes of data over 10 gig links in a DAS cluster. With EMC Isilon, it's really, really quick. You can get into moving tons of data. In many cases, you're not moving the data because it's already in our storage system. And we've done some analysis where in-place analysis can occur right away with this platform compared to data, or DAS rather. So here's a picture of how primary data gets spread across the nodes in an Isilon cluster. No replications required. We've got built-in erasure encoding. And unlike what you see in Even, again, this is from Hortonworks, where they see a 25% hit, as you mentioned earlier. There is no hit. This is integrated with our OneFS operating system. You can't turn it off, and it gives you easily 70% utilization. On average, we're seeing 75, 80% utilization on the storage, which is very, very powerful. The interface, as I said, is not written in Java. It's written in C++. It's embedded into the operating system. All the metadata associated with name nodes are on SSD drives, typically. So you could stream the metadata in and out much faster on any node. And what we do is we basically direct every client on a Hadoop cluster and load balance them to different nodes. So it doesn't matter where they get load balanced to, the metadata is going to be there. And if a node cluster were to fail, we have this concept of an IP pool. So we'll reallocate that IP address that the client was communicating to and alias it to another node. So there's no downtime. The job just keeps running. There may be a little latency, a little hiccup, while a physical node were to fail in EMC, but the job completes, which is very, very powerful. That back end, as I mentioned earlier, is all InfiniBand, and that's where all the data node connectivity and communications occur. So all that overhead, all that overhead that you saw earlier with TCP IP communications and all that, that goes away from the front end network. So another benefit that you get with EMC is your Ethernet client-facing network utilization is improved, because you just offloaded all the data node communications on the back end from that network, which is very, very good. Protocol support, I think I hammered this home. One thing's kind of cool, if you look at the big data environments and a lot of DAS deployments, those are pretty much used by your data scientists only. You don't really see Microsoft users mounting HDFS files and doing analytics. You can do that now with EMC Isilon. So you could literally have your Word docs or whatever docs on an HDFS partition, also being accessible through SMB. So it may have gotten there through SMB or HDFS or NFS, and you could share that with your Microsoft environment if you wanted to, right? Access file, so here's, I do have a slide. So here's an example how you could literally, from a Windows desktop, drag and drop over a network share and put files into your HDFS store if you wanted to. It's pretty cool. Some people really enjoy this. Depends on your use case again. You could do the same thing with NFS. I already mentioned this. So on the right, because of our access zone, we now support I'm in the middle of completing the validation with IBM Big Insight, so we have deployed that in production at a few large customers already. Hortonworks is completely certified, so is Cloudera. Those are the big three in addition to Pivotal. I don't want to seem biased, EMC owns Pivotal, but they've gotten out of the distribution space. Are you all aware of that? Where Pivotal is now making Hawk, and well, Hawk is an incubator project. They make HDP, which is a really cool product. You should keep an eye on that if you're familiar with Gemfire technology and memory database analytics. That's all coming from some cool technology we developed at Pivotal. All right, so some advantages to keep in mind with HDFS protocol stack. It's definitely written in C++. Supports parallel processing. It's a true scale-out solution where you get two 10 gig on the front end and two InfiniBand on the back end. Soon to be 40 gig interfacing on the front end. Support for cloud pools. I'm going to talk about that right now. And you could administer everything over the web if you're not a command line type person, but we have an extensive CLI interface as well. This is what the interface looks like, where you could stipulate your, you can enable your block size, enable web HDFS. It really is plug and play. And what's nice is when you define your Hadoop cluster, there's only one name node from the perspective of the Hadoop distribution. There's only one data node. But in reality, we're load balancing that in a scale-out fashion across this architecture. So everything gets simplified too, even from the Hadoop administration and interface, the configuration files, etc. So I do have a slide here on HDP. It's powered by Apache Hawk. Again, that's an Apache incubation project. But that's the future, in my opinion, of SQL on Hadoop. Our goal is to provide native SQL into that Hadoop stack. And if you want to read about Apache Hawk, and that's all online, just Google it. But I did do some tests. Keep in mind, I write performance papers for EMC as a living, and I just want to forewarn you, this is just something I did for the Hadoop Summit. This is not an official white paper quality report. It's just something I want to share with you. So take this with a grain of salt, because I just put together a small lab and show you, one, integration with Hadoop and Isilon to give you an idea. But the performance numbers, although they're meaningful, I don't want you to walk away from here thinking this is the best performance. It depends on the number of nodes. In this case, this is what we had in terms of the lab: 8 nodes, 64 gig RAM, 10 drives, 10 gigabit interface, jumbo frames was enabled on the network. And on Isilon side, we have two versions of OneFS. 8 is the latest one. A lot of enhancements went into that, but we'll get into the scenario here. Sorry, went backwards. So what was tested? HDP 2.0. Again, I had a beta. This is beta stuff that I did. This is an incubation project, but we ran it against OneFS 8 and OneFS 8 in secure mode. By secure mode, that's Kerberos mode. And let me just check on time real quick. Okay, we're okay. So what you'll find, let's just get into the results. Anyone familiar with TPC-DS? You know what that is? Okay. So there's different benchmarks, right? For MapReduce, TerraGen it's, you're generating a bunch of data and you're testing write capabilities. TerraValidate or TerraSort will read and test different things. TPC-DS is a good benchmark to test NoSQL environments. And in this case, we used a scale factor of 3 terabytes, a single and 5 concurrent users, and we just literally looked at how long it took for the jobs to complete, right? And generated the data, analyzed it. So here, in terms of load and analyze results, again, this is not an official thing. This is just something I did for the Hadoop Summit. Here, what we could see is on the bottom, here's your DAS. This is OneFS secured, meaning Kerberos was enabled. This is OneFS version 7, which was the previous release of code we had. And this is OneFS non-secured. So what we're showing here in terms of analysis is in red, load is in blue. So for DAS, the analysis was 1.2 hours for this particular 3 terabyte load. And for load, was 1.8 for DAS. And with OneFS 8 secured with Kerberos, this wasn't secured, we actually got faster load time on Isilon compared to DAS. And the 1.3, it's a little slower on the analysis. With our previous release of code, the load time was, and this was non-secured, was faster as expected. The analysis, though, was much higher. And this implementation was written in Java. So this is another reason why we know for a fact using C++, C, and these embedded operating systems go a long way. And this is the OneFS without security on version 8, the C++ version. So overall, you could see that analysis and load time, actually the analysis and the load time was better, and in both cases here in secure and non-secure environment. And then in terms of Java versus C++ with Isilon, what we saw is basically a 30% difference in performance. So if you're going to roll out Isilon and you have the opportunity to run 8, I'll highly recommend you run 8. If you need to run 7, that's fine. Just be aware there is a easy, based on jobs, and this, gotcha, 5 minutes left, performance, 30% right out of the bat. In terms of DAS versus OneFS8, we saw a 30% performance over DAS with EMC Isilon. I wasn't expecting this, to be honest with you. I thought it might be 10%. We actually performed very, very good in this NoSQL test, which goes beyond TeraGen and TeraVault. So here are some of the results that we got in terms of Isilon over DAS. Same compute, same workload. All we've shifted is we moved the name node and data node from DAS to Isilon. Same environment, same network, everything else the same. 5 users. This is where it really got interesting. The previous test was with 1 concurrent user. As we increased the users, our performance also increased. And a lot of that has to do with our metadata acceleration, layer 3 caching, amount of global cache we have on Isilon is way higher compared to DAS. And in these cases, they helped quite a bit. So if you're familiar with the TPCS scores, with OneFS8, that gave us the highest score of 6. When you go to secure mode, which means Kerberos, we were at 5, and compared to DAS at 3. I'm not knocking DAS, this is a nice result to see. You know, there's a lot of people out there, and I was one of them, that just didn't believe shared storage makes sense for Hadoop. And after going through this changed my mind, so I figured I'll share that with you as well. Non-disruptive upgrades is supported with Isilon. So you can upgrade as clients are communicating. They automatically get directed to different nodes. I can't tell you how many people love this kind of administrative feature you get with this solution. You could also roll back if you have to. Features, cloud pools. You can now tie Isilon to your cloud provider if you wanted to do massive archiving to a third party. So you could have your real-time jobs running on Isilon, and then as you archive data, right, on slower nodes, and if you want to archive data for a long period of time, you can tie Isilon to AWS or VirtuStream or Azure, and we could handle all the offloading for you transparently. You don't have to do anything in Hadoop. This is very cool. This feature came out with release 8, by the way. So basically, Amazon, Microsoft Azure, and we own VirtuStream, so we can tie these solutions right to those cloud providers out of the gate. It's just a license. All you do is buy a license, enable that license in Isilon, you're good to go. Capacity, we're up to 68 petabytes. Once you enable cloud pools, obviously it's as big as you contract with the cloud provider, right? Storage platforms, I would say X is what I typically recommend, X410s for our Hadoop production stuff. The HD nodes are for archive, and then we're doubling the performance on our next release of hardware. So we spent a lot of time with software, now we're looking at hardware as well. And then the Hadoop events, I think I got 1 minute left, so I'm going to go through this really quick. So basically, you'll see as you start getting familiarized with Hadoop, there could be network congestions. And one way to resolve that really quickly is you add, the fact that we built in Smart Connect is how we load balance connections from the clients to the data nodes and name nodes. And that's all back-ended on InfiniBand. So all I do is just scale this out and keep growing this. It's a little more difficult with DAS. We also find that you take up a lot less rack space. You can segregate compute and storage with Isilon. I'm running out of time here, so I'll make these slides available to you. These were just failure scenarios and highlighting the benefits between Isilon and traditional Hadoop and what the difference is. But that's pretty much what I have for you today. I hope you learned something, and If you need to talk to me, I'll be around at the Hadoop our EMC booth. Also, I do a lot of third-party ISV validation. So if you're an ISV and you want EMC to adopt your technology, I'm the man you want to speak to. And if you have something interesting, let me know. Question? So there's a product that's very interesting. Waterline is a product I reviewed in recently, and they have the best tagging solution I've seen. We've deployed that at some customers, and the customer said the same thing. So that's one solution. Ativio's another. There's a few, but Waterline was very interesting. Yeah.
One of the challenges you're facing, I don't know which version they have in Isilon, is the protocol doesn't support ACL controls. We're not able to run Ranger with our existing version.
Yeah. So Ranger takes advantage of some extended attributes which we haven't incorporated to the protocol. So Ranger supports is today for authentication not a problem. Authorization, we're adding protocol hooks in the next 2 months. So you got to wait 2 months.
But I have to use 8.
Yeah, you're definitely gonna have to use 8. And we're pushing everyone to 8. You want to use 8. The performance has been doubled. There's no reason for you to stay on 7, and that's been G8 a couple of months now. But
We can upgrade the operating system when I fetch to the next version.
oh, sure.
I don't buy the new appliance for it.
Oh, nothing. No, yeah. We spent a lot of time making upgrades easy on that. Yeah. Yes. That's a great question. So the question was Mbari metrics, do we integrate that? The answer is right now we just say we're healthy. We're now, yeah, okay. Yeah, I got you. I'm sorry. I'll talk to you outside.